In this video, we're going to look at how we can apply the geometric series to help us calculate the value of the loan repayment M. The question we have here is, Sarah borrowed $600,000 from a bank to purchase an apartment. The bank charges interest of 9.6% per annum, compounded monthly. At the end of each month, Sarah makes a repayment of M dollars. She continues making the same monthly repayment of M dollars until the loan is repaid in full after 30 years. Let AN be the amount owing after N months. Part A, we want to show that A3 is given by this expression. Before we start with these type of questions, one thing to be careful with is the interest rate. In this question, we're given that the interest rate is 9.6% per annum, but because in this question, interest is being compounded monthly, this value of interest rate must be adjusted to be the equivalent interest rate per month. Since there are 12 months in a year, this is going to equate to an interest rate of 0.8% per month. So let's start by working out A1. A1 is the amount owing after 1 month. Well, for A1, your loan starts with $600,000, and after the first month, the bank is going to charge you 0.8% interest. So the amount owing will become 600,000 times 1.008, but then you make a repayment of M dollars. So we subtract M from this expression. To calculate A2, the amount owing now is A1. So what the bank is going to do is they're going to calculate interest based on this amount. So we're going to multiply by 1.008, and then you're going to make a repayment of M dollars. So if we expand this one, we're going to get 600,000 times 1.008 squared minus M times 1.008 minus M. Now for A3, the same thing applies. This now becomes the amount owing, so the bank is going to calculate interest on that. So taking the expression A2, 600,000 times 1.008 squared minus M times 1.008 minus M, and all of this multiplied by 1.08 because that's the interest the bank is charging you, and then you're going to make a repayment of M dollars. Again, we're going to expand the bracket, multiplying 1.008 to every term inside this bracket. This is going to give us 600,000 times 1.008 cubed minus M times 1.008 squared minus M times 1.008 minus M. And this is the expression for A3, which we're trying to prove. For the second part of the question, we're now going to find the expression for AN. So using the result from part A where we got the expression for A3, and because this is a recursive relation, I'm going to replace the 3 with N so that we get the expression for AN as being equal to 600,000 times 1.008 to the N minus M times 1.008 to the N minus 1 minus M times 1.008 to the N minus 2, all the way to the last term, which is minus M. Next, I'm just going to factorize out the M. So we have minus M out the front, and inside the bracket 1.008 N minus 1 plus 1.008 to the N minus 2 plus all the way to the last term, which is just 1. And just to make it easier, I'm also going to rewrite the terms in reverse order. So I've got minus M, 1 plus 1.008 plus 1.008 squared plus all the way to the last term, which is 1.008 to the N minus 1. What we now have here is a sum of a geometric series, and we can simplify this using the formula Sn is equal to A times Rn minus 1 over R minus 1. A is the first term, and in this series here, A is equal to 1. R is the common ratio, which is 1.008, and N is the number of terms. And in this series, we have got N terms, so N is just equal to N. Next, we're going to simplify this. So we have AN being equal to 600,000 times 1.008 to the N minus M and then applying the series formula, we're going to get 1 times 1.008 to the n minus 1, or divided by 1.008 minus 1. This simplifies to 600,000 times 1.008 to the n minus m. Now, 1.008 minus 1 is 0.008, and when we take the reciprocal of that, that's going to give us 125. And so the final expression for an is simply equal to 600,000 times 1.008 to the n minus 125 m times 1.008 to the n minus 1. We're now up to the last part where we're going to calculate the value of the monthly repayment M. In this part, we're going to need to use the result from part B where we derived the expression for AN. If you recall from the question, the loan is to be repaid in full after 30 years. But because we're making repayment monthly, this would equate to a total of 12 times 30, which is equal to 360 months. So what that means is the value of A360, the amount owing after 360 months, should be equal to 0. So we're going to sub n for 360 and solve for m. So we have 600,000 times 1.008 to the 360 minus 125m times 1.008 to the 360 minus 1 is equal to 0. So 125m times 1.008 360 minus 1 is equal to 600,000 times 1.008 to the 360. And then dividing both sides by 125 times 1.008 to 360 minus 1. And then putting this into the calculator, we're going to get the value for M, the loan repayment per month, is equal to $5,088.96. Thank you for watching the video. Hope you guys enjoyed that. If you are interested in more videos on this topic or other topics, please have a look at our channel. If you haven't already, don't forget to subscribe. We hope to see you all in our next video. Bye for now.